Yes, we are going to start a new chapter, and the chapter's name is Simple Harmonic Motion. And the other name for simple harmonic motion, you will not be aware, is called oscillation. See what we did? Okay. Now, this chapter, we will do some details about SHM oscillations. But the things we need to know in this chapter, before that, we need to know something. To enter the chapter, we will need to know a few things. The first thing that you will need to know is the relation between displacement, velocity, and acceleration. It's mandatory to know the relation before you start the chapter. And as we know, unit of displacement is meter. How do we know? Because we did it in the previous recording. And the unit of velocity is meter per second, and the unit of acceleration is meter per second square. And if I want to get velocity from displacement, it is dx by dt. That means differentiation of displacement is velocity, and differentiation of velocity is acceleration. Or I can also write it as double differentiation of displacement. That means from displacement, if I do double differentiation, I get acceleration. Everyone, please make a note of this because this is very important. You should know velocity means differentiation of displacement and acceleration is differentiation of velocity or double differentiation of displacement. And SI unit of displacement is meter, SI unit of velocity is meter per second, SI unit of acceleration is meter per second square. Please make a note. Very important to know this before we start the chapter SHM. Yes, very good. Okay, what is the full form of SHM? Simple harmonic motion. And the other names for SHM is oscillatory motion and vibratory motion.
1 second.
Okay, okay, take it.
Done, sir.
So what is the other name for SHM? The other name for SHM is oscillatory motion, or it is also called as vibratory motion. Or it is called to and fro motion. All these mean the same. Simple, they don't mean the same actually, but for you it mean the same. Simple harmonic motion, oscillatory motion, vibratory motion, to and fro motion. These are the other names or alternate names for simple harmonic motion. Now, what does each term stand for? I'll explain in the next class. For now, just make a note. The other names for simple harmonic motion is oscillatory motion, vibratory motion, and to and fro motion. Okay, now let me give you one or two problems on displacement, velocity, acceleration, and then you're good to go for today. Okay, displacement of a body x is equal to 6t square. What is velocity at time equal to 3 seconds? Start. Already done it in part 1 in other chapters, correct? Already aware. So now give me the answer quickly. Displacement of a body is 6t square. What is velocity of the body at time equal to 3 seconds? Start. Okay, Drishti, one answer. Okay, now listen. Velocity is nothing but differentiation of displacement v is equal to dx by dt. Now, what is differentiation of 6t square? Can I say 6 is a constant? I am assuming you know a little bit of differentiation by now. 6 is a constant and differentiation of t square is 2t. X power n is n into x power n minus 1. Therefore, velocity is equal to 12t. But I want velocity at 3 seconds. Therefore, it is 12 into 3 is 36 meter per second. And how many people gave me the right answer? I'll tell you. Akshay, Rebecca, Priyanka, Jyotika. Shubham, just check your answer. Pooja, Drishti. That's it. Others have not answered. That means either you don't know differentiation or you've forgotten the formula or both. Okay, either way, not good. You should know basics of this. Okay, at least now when I'm writing on the screen, differentiation, you should know very simple differentiation and substitution also. And I told you velocity is nothing but differentiation of displacement. Okay. Okay. Next question, can we go?
Yes, sir.
Yes, sir.
Yes, sir.
Displacement is 4t cube. What is acceleration at t equal to 1 second? Start. Drishti, good. One person has answered. Pooja, good. Second person has answered. But I've got two different answers. So let's see. Jyotika, okay. Three different answers from three people. Priyanka, okay. So I'm getting Neha, okay. I'm getting answer as 12 and 24. I'm getting these two answers maximum, 12 and 24. Now only one of them can be correct. Advita, fine. Only one of them can be correct. Akshay, okay, 24. Think about it and answer. Okay, Drishti, Diksha, fine. Sonu, Ashwin, fine. Okay, now listen. X is equal to 4t cube. Therefore, velocity is differentiation of displacement. So 4 as it is, differentiation of t cube will be 3t square. Therefore, velocity is 12t square. Now, acceleration is nothing but differentiation of velocity. Acceleration is nothing but differentiation of velocity. 12 as it is. Differentiation of t square is 2t. Therefore, acceleration is 12 into 2 is 24. Now I need acceleration at t equal to 1 second. Therefore, my answer for acceleration is 24 meter per second. Now answer is not 12, answer is 24. Did you guys get this? Okay. So one
Yes.
last problem. Give me this answer and then we stop for today. Okay. Same way, velocity and acceleration. Start. Answer maybe is this. I'm giving you a hint. Maybe the
Yes,
answer
sir.
is this. Okay, now let us start. Velocity is differentiation of displacement 6 as it is. Differentiation of t power 4 is 4t cube. So answer of velocity is 6 4s are 24t cube. Okay. Now acceleration is 24 as it is. Differentiation of t cube is 3t square. Therefore, acceleration is, what is 24 into 3?
72 t squared.
Correct. Acceleration is 72 t square. But I want acceleration at time t equal to 2 seconds. Therefore, 72 into 2 square. Therefore, I will get answer as 72 into 4. Answer will be 288 meter per second square. Everyone got this much?
Yes, sir.
Okay, got it. Fine. Time up. That is the time. What time up? Okay. With that, we will stop for today. Next class, be ready with the module. It is module 5. In that, it is the second chapter, simple harmonic motion. Okay, module 5, simple harmonic motion. So I will see you next week. Thank you, all of you. Bye-bye and happy Raksha Bandhan. Okay, bye-bye.
Thank you so much, sir.
Thank you. Bye-bye.